30 knots, 100,000 tons of steel, $13 billion of floating firepower, and a single command that can turn controlled power into controlled chaos in seconds. Imagine the ocean at dawn. The horizon is calm. A nuclear-powered aircraft carrier slices through the water like a moving island. Jets rest on the flight deck. Radar dishes rotate silently. Deep below, reactors burn with contained fury, generating enough power to light a city. Everything feels unstoppable. Then suddenly, over the bridge communication system, the order is given. Full astern, all engines, reverse, at 30 knots. Before we go any further, subscribe to Sea Warfare Explained, because today we're diving into one of the most extreme maneuvers a modern warship can perform. A moment where engineering, physics, and human decision collide. Now understand this clearly. 30 knots may not sound dramatic compared to a fighter jet, but for a ship weighing over 100,000 tons, it is enormous. At that speed, the carrier is carrying staggering kinetic energy. It is not just moving forward, it is charging through the ocean with the force of a small mountain in motion. And mountains do not stop easily. When the engines are ordered to reverse, nothing happens instantly. There is no sudden brake. Instead, deep inside the hull, massive steam turbines begin reducing forward thrust. Propeller shafts, some longer than a city bus, slow their forward spin. Then they begin to rotate the other way. This is where the violence begins. Those propellers are the size of small rooms. When they reverse at full power, they are not gently slowing the ship. They are attacking a wall of rushing seawater that is still flowing forward along the hull at 30 knots. The water does not cooperate. It resists. Cavitation forms instantly violent bubbles that collapse with explosive force around the blades. The noise underwater becomes thunderous. Shockwaves travel through the metal shafts. The stern of the carrier trembles. Sailors feel a deep vibration under their boots. The hum of the ship changes pitch. The ocean behind the vessel erupts into white chaos as forward momentum clashes with backward thrust. But here's what most people never think about. Even at full reverse power, the ship does not stop immediately. Momentum is king. A carrier moving at 30 knots may need several miles to come to a complete halt. That is the reality of moving 100,000 tons at speed. Reverse thrust only begins a battle against physics, and physics always takes time. Now imagine this happening during a combat situation. An incoming torpedo has been detected, radar shows a fast-moving surface threat. Or perhaps there's a sudden navigation hazard in restricted waters. The captain must act instantly. There is no time for gentle slowing. But reversing at this speed creates new dangers. As the propellers fight against forward motion, water flow along the hull becomes chaotic. The rudders lose clean water flow, reducing steering precision. For a brief period, the ship's handling becomes unpredictable. And unpredictability at sea can be deadly. If the carrier turns slightly during this deceleration, it may expose its broadside, the widest and most vulnerable angle, to enemy fire. Every movement must be calculated. Inside the Combat Information Center, officers monitor speed drop, heading drift, and sonar conditions. Engineers watch shaft torque and temperature readings. Even minor abnormal vibrations are logged instantly. Because if propulsion components are damaged, repairs are not simple. These are not car parts. These are multi-ton precision systems designed to operate under incredible stress, but not carelessly. The ocean behind the carrier becomes a boiling storm. Reverse thrust creates powerful suction currents. If near other vessels, smaller ships could be pulled dangerously close. In shallow waters, sediment clouds could reduce visibility dramatically. The stern may squat lower as hydrodynamic forces shift. The bow may rise slightly. Every shift changes how the hull interacts with waves. Now think about the flight deck. Aircraft operations halt immediately. Fighter jets are chained down. Crew members secure loose equipment. At this scale, even a slight imbalance can send heavy objects sliding. Below deck, maintenance teams brace themselves. They've trained for this. Emergency procedures are clear. But training does not remove the stress of the moment, because every sailor knows what is at stake. A $13 billion supercarrier is not just a ship. It is national strategy floating on water. It carries air power, surveillance capability, missile defense, and thousands of lives. Damaging it during an emergency maneuver could affect an entire region's balance of power. Yet these ships are built for resilience. Naval engineers design propulsion systems with safety margins far beyond normal operation. Shafts are reinforced, bearings are oversized, redundancies exist everywhere. Nuclear reactors provide stable power regardless of sea conditions. This is not guesswork engineering, it is decades of design, simulation, and testing. Still, no system is invincible. As speed drops from 30 knots to 25, turbulence remains violent. The ocean's resistance increases as the ship's energy dissipates into heat and motion. The wake shortens slightly, but the water is still roaring. At 20 knots, the vibration begins to soften. Steering response slowly improves. The rudders regain more predictable flow, but the ship is still moving faster than most vessels ever will. Inside the bridge, the captain remains calm. Orders are precise. Adjustments are measured. Panic has no place here, because fear spreads faster than fire at sea. 15 knots, 10 knots, the ocean's fury begins to calm. The boiling white water behind the stern turns into heavy churn. Reverse thrust continues pushing, eating away at remaining momentum. Finally, below 5 knots, the ship feels manageable again. Steering stabilizes, the violent shaking becomes a controlled hum. And eventually, the massive warship slows to near stillness. But the story does not end when the ship stops. Immediately after such a maneuver, inspections begin. Engineers analyze shaft alignment, vibration data is reviewed, structural stress sensors are checked. The hull is scanned for unusual readings. Because extreme maneuvers leave invisible fingerprints, and in naval warfare, small weaknesses can grow into large vulnerabilities. What makes this scenario so fascinating is not just the physics, it's the mindset. Reversing a $13 billion warship at 30 knots is not reckless. It is the understanding that sometimes survival demands extreme action. Power at sea is not only about speed, it is about control. True naval dominance lies in mastering momentum, not being controlled by it. The ocean is vast, patient, and unforgiving. It does not care about budgets, flags, or advanced technology. It responds only to force and motion. So when a supercarrier throws itself into full reverse at 30 knots, what you're witnessing is more than a maneuver. You're watching a battle between engineering and nature, between human command and physical law, between momentum and restraint. And if done correctly, the outcome is extraordinary. A floating city, powered by nuclear fire, bending its own massive energy to the will of a single order, full astern. Because at sea, survival is not given to the fastest ship. It belongs to the one that understands when to slow down and how to do it without losing control. And that is the true power behind the $13 billion warship.